All right, so I got the recording started live. Not as wider of an audience as I thought, but it's okay. At least it's with my team here. So I'm at the Tech Symposium hosted by Cal Poly Swift. So thank you guys for hosting this event to have a lot of different professionals and sysadmins come together, students as well. Just as a little background, let's see. There we go. I did graduate from Cal Poly in 2006. I've gone back to DeVry for my second bachelor's degree, and I've worked for a few tech companies. First started with an ISP, Link Line Communications, played with DSL and T1 routers and troubleshooting internet connections. I worked for Ironside, which did indoor analytics and positioning, and a lot of flexibility to learn there. And now I'm at Azusa Pacific University, where I service about 10,000 students and 2,000 faculty and staff.
So, Cal Poly grad?
My first bachelor's was in behavioral science. I was in the College of Letters, Arts, and Sciences. I think it was Building 5. Yeah, it was a good stepping stone for trying to figure out where I really want to be. So I wanted to encourage what I built this talk off of was my going to Scale for the first time. It's a Southern California Linux Expo. I took away from that learning Docker container applications and more deeply SaltStack. I also wanted to share how a presenter, Ski, which is one of the leaders of the League of Professional System Administrators, of which I'm a member of, gave a presentation on incident command system, which is useful for environments when you're thinking about high availability and how to react in case something goes down. So LinuxHA is comprised of a heartbeat. You got to tell all your nodes in your cluster who's up, who's down, and then you need something to orchestrate what happens in case one of those nodes goes down. And then the way you have a reactive state is that you have these resource scripts. So one resource is a virtual IP that they all share. And at any given time, that virtual IP could go to any one of the other nodes to take over whichever node dies. So somebody reboots a system by accident. You got 2 nodes in your cluster, one will fail over, no problems. And so I have these 3 systems right here that are in that cluster. So Docker itself, there was a high-level overview earlier. I'll just go through some of the base topics. The security aspect, it gives you a chroot jail. It is in a jailed environment, so any attacker would be isolated or siphoned to that particular container. The goal of Docker itself, they don't actually do the LXC, which is the Linux containers. That's been around for a long time. It's what Google has actively developed and used in their environment. But Docker comes with making it easy. And if you notice with that image you just pulled, Docker pull CentOS, shouldn't have taken more than 2 minutes to download that image. And you already have a container ready to go. You can update it, install apps, whatever you want to do that container. You could copy that container. You can make different versions of it. It makes it really portable and easy to manage. Docker Hub is basically the free version of images that people maintain. Debian maintains their repo. CentOS and Fedora, Red Hat flavors, they maintain their own repo. These are public facing, anyone can make them, so they're not vetted. So depending on your environment, you may want the Red Hat version, which is either through Atomic or OpenShift. But Docker Hub is free for everyone to have at, and it's a free resource to get a bunch of images. So you could get certain things, like let's say you run a very specific version of a LAMP stack. It may already be built into a container, or at least most of the components. And that way you don't have to do the grunt work.
So Docker and pretty much you just said OpenShift are pretty much
kind of the commercial versions, the enterprise versions. Yeah. OpenShift, Atomic Host itself is a host operating system. You have to get a license, and it calls back to its repository. That's a Red Hat repository. So instead of you going to Docker Hub, which is public facing and free for everyone, you go to the Red Hat Hub or whatever the equivalent is for Red Hat Network probably, for their container images. and they're vetted. They say they're ready for production and they're secure. So the difference between the two. But and just to keep everyone entertained, I do have a funny picture of my kids. Just to, these talks can get really boring really fast. And I don't know, if you want to laugh at my daughter who wanted to take a nice photo for Christmas, you're welcome to. The configuration is pretty simple. You have a Salt Master, you have Salt Minions, and then you have Dockers within each one of those hosts. So
It's like a big thing out there. It's like walking out good like.
pretty much all I did, and that's why I was curious if there are any exploits to even try against Apache, but it's a simple CentOS image, and it's got Apache in it. That's it. Don't have any PHP, don't have any CMS, I don't have anything else that is, that would likely make the container vulnerable, but nonetheless, I encouraged it because that'd be interesting to find. If you could break into a container and then from the container, find the pathway into talking to the underlying kernel and the underlying host. Again, it's supposed to have these SE Linux policies and other methodologies that thwart that. So, yeah. So the diagram, I have my.
Did anything yield from that at all, or what? He was saying, say about exploiting as far as that. I did.
Yeah. But it's at home, it's on my router. It hits a VMware ESXi VM server. The 3 nodes are in there, or the 3 VMs are in there, which each one is a Linux HA node. And then I call the other containers nodes as well. They're kind of container nodes, I would call them. HAProxy does the networking for all this. It just comes in on it goes port 9000 to port 80, divvies it out to all the containers. And it does it just in a round robin. So they all get distributed. Each one gets hit equally. There's no, it distributes the load, right? So there's my Docker file, which in that directory, it's got a basic HTML index file. And it's got a bunch of commands that at the time of building this Docker image, it will say get the CentOS latest version. It'll say who's maintaining this Docker file. And then from there, it runs a series of commands that I orchestrate it to do. I want it updated. I want Apache installed. Clean out the directories for when you have your yum caches. And then run a script. I made the run.sh script. Add the files to a certain directory, give them permissions. And then the very last statement is important. When you run a container, it only exposes what you define it to expose. If you don't expose any ports, there's no network to it. It's just simply running an application. And for a developer, that might work fine because there's ways to get into the container as if it's like a shell or like a console. You could poke around with the application, but for the most part, unless you expose something with the container, it does not connect to a network or anything natively. You have to state that somewhere. So it also could, this is done in the Docker file, could be done in Docker run. You could do Docker run and then run some other switches and commands and expose multiple ports if you needed to, depending on the service. So Red Hat, they have Atomic Host, they have OpenShift, they put SE Linux. Kubernetes I haven't been able to play with yet, but it's supposed to allow you to orchestrate containers on demand, and then you could have them spread across a bunch of cloud providers. Yeah, I think they're in the Bay Area, and they have Texas. So.
Because the wife went to like some photography thing, and I guess one of the people that works for that company
is tied in.
Yeah, it's like massively tied into that. And,
Okay. Build your network, build your connections. So pretty much, if you don't have high availability, you'll find yourself in this position where Nagios fills up your inbox. PagerDuty is calling you like crazy, and then pingdom's going off that like, hey, these critical services are down. So before we get to this point, that's what you.
Yeah, PagerDuty at 2:30 in the morning.
Yeah.
That's 2 mornings.
Yeah. So before you get to this point, what you really want to do is have this kind of structure or architecture. So again, you're only as good as your single point of failure. Right now, there's a load balancer, but this load balancer exists on 3 different virtual machines. Now, if you increase your hardware infrastructure to have multiple servers, multiple VMware servers in this case, and you'd have high availability and redundancy for the hardware level. Add another step of the network layer, you need to figure out, redundancies in that realm as well. If you assume those are set up, that's a bad thing. You should dig at and see what your infrastructure is, see what you could afford, but those should be considered in your production environment or in the data center that's hosting your stuff. So if it's Amazon or if it's, what's down the street? What is that? Not DreamHost, but there's a couple in Orange County that aren't nearby, but a couple different host companies. You want to make sure that they have that for you. So if they have high availability on their back end, then your front end becomes your responsibility. So if you have a load balancer spread across 3 virtual machines, let's take one of them down. So let's purposely go to PCS status is a command for LinuxHA to check your nodes. So right now online, it shows that I have the management and the other 2 nodes. Again, these are virtual machines. If I simulate taking one down, and at the same time, so notice right here on the bottom screen, you'll see which nodes are online. The one that is the master is CentOS node 1. So I need to go to that node. And I'm going to run my script here. And it's going to simulate an outage. And now when I check my status, it's now shown up on the management. So I set the aggressiveness to 5 seconds. If within 5 seconds, a node is detected as down, switch it over to another one. And so in 5 seconds, I've had a virtual IP be re-provisioned to a new node. And it took with it DNS server, which is bind or named, and named, and HAProxy. So my load balancer has resiliency of 3 nodes. So if 2 of them fail, there's still 1 more that can run the service. So, and again, if you spread that across independent hardware that's on the back end, you're increasing your availability. So this is at the VM, this is at the guest VM level. So let's go to the next level with Docker. So now I have 5 containers in each one of these nodes. So if we look at, oh, this needs to be refreshed. We have 15 nodes. Let's take one of the nodes down. So if I go here, and I could do that running Salt. So I do Salt. I'd say which node I want to issue the command to, command.run. And within that directory, I have a special script that will stop the Docker containers on that particular node. So while that's running, should, as soon as it starts to, the yellow to red is a convention of HAProxy where it does a health check. If it cannot respond to the request, which is just a basic GET request, it will detect it as that it's down, and it'll take it out of the pool. So while it's taken out of the pool, you'll notice the containers are still loading to the other available nodes. So that way, you could add and remove Docker containers on the fly with little to no service disruption. So you're, yeah.
Or is this your own interface that you make?
No, this is HAProxy's.
I was gonna say, 'cause I've never actually seen
Yeah.
hell of a lot more responsible.
So a commercial product for this, Citrix NetScaler. There's licenses for it. It does all this, the same bells and whistles. And actually, there's some interesting papers that compare NetScaler to HAProxy. And I want to say Stack Exchange is one of the bigger shops that uses HAProxy. I haven't read their white paper, but they have some kind of report on it and how they leverage it to load balance and maintain their infrastructure. So let's say I took those out and I actually want to remove them and I want to deploy new nodes. And these new nodes are going to have new information in it. Let's say it's like a version 0.1 to 0.2. So I have a script that I set up for that. And so my demo is now going to say, take the next iteration of the Docker image and deploy that one instead of the one before it. It had deployed it. If we look at our request, we're going to see a little bit different results. The next version has a hyperlink for the Tech Symposium website. So in the matter of the last, 20, 30 seconds I've been talking, I just deployed new code per se on the next update without any interruption to the existing servers. So now I have a hybrid environment. I have the later code running and have the older code that's still running. So I could just go through the other nodes. So if I go through and just change the node to node 2, stop the containers that are running on that. And then on node 2, I should see them drop. And I'll go through the same process. I'm going to stop them, remove them, deploy from the new image, the new container image. And so right now, they're just about to get pulled out of the pool.
So this is you just really being able to do a nice solid code update. Pretty much.
Yep.
Transitioning from one, still staying balanced and everything else.
So if you combine everything, everything's balanced, everything's has availability. Because imagine if you scaled this to say my home server, a data center that is like rack space where I put bare metal servers in there, and then I got Amazon and I don't know, DigitalOcean. If you have the right software-defined network that says, hey, you're on the same flat network, all these nodes are available on that network, your single point of failure are your load balancers. So again, if you were to architect load balancers within each of those infrastructures, then it comes down to just the host name, the actual DNS and A record. Now you throw in dynamic DNS, which could update with a 30-second time to live. I mean, you're looking at no more than 30 seconds of downtime if you have it automated and set up right. Because as soon as one of your load balancers is down, cool, update dynamic DNS, or have dynamic DNS do its own automation as a health check. Say, hey, this load balancer went down. Bounce it to another one. Then next thing you know, it's distributing the load across all of the infrastructure from a different location. So, San Andreas earthquake hits on the West Coast. Everything's down over here. Hey, your Virginia site's up on AWS. No sweat. So these are just, again, it's coming from my small to medium-sized business experience. I couldn't say this would work necessarily on the best scale for larger enterprises, but they would probably do this using Kubernetes or OpenShift.
I was going to say, truthfully, I mean, just based off of what we do, this would be massively beneficial.
Yep. And then right there, I just updated another node, new code. I should see more consistency on the hyperlink being there, because now there's 10 that are updated, 5 that aren't, and I can do the same exact process.
Mm-hmm.
If I wanted to roll back, easy. I go run my script of the original image back into production, no problem. No interruption, So this really changes. Do you need a 2 a.m. maintenance window? I mean, depends on the application. That's still up for discussion, but you're less likely to if you want to. One of the ways Google presented it was called canary testing. So what they demonstrated was Kubernetes. They gave it a setting of 10% of their load balancing requests will go to the brand new code, and the other 90% are going to go to the normal production containers. So that way you can monitor and put sensors and log that 10% and see how the code's working in real time in a production environment. If you want to be aggressive like that, you have all these tools, free and open source, available to do that. So it's just a matter of understanding how to maintain it, which the last talk we were at. I don't have the setup in Git at the moment, but I would have my scripts in GitHub. I would, be developing on them, staging them, testing them, and the same for the Docker file. So for each iteration of the Docker file that I improve it, I want to maintain that version control. So on top of that, you could even check what packages are installed by running salt commands to audit your system. So if you were to say salt all nodes, and let's say we wanted to find out Docker -- version. Oops, there we go. Interesting on the master.
Didn't you take that one down earlier? No, that was new one.
Yeah, that should. Oh, that's interesting. I have the master as a minion, and it didn't return what I would expect. But, oh, there we go. So what that might have been is best practice, which I should have done. You're supposed to put a little bit of a timeout because you want to give enough time for the master to broadcast and say, hey, I need some information. And you need that timeout to have enough time for the return. So the return didn't come back in time. Even though it's local to the system, yeah, your best practice is to put a little bit of a timeout just in case, and depending on how you have it set up in your environment. But pretty much I can control these at will with Salt. I could, if I were to use GitHub on all of them, git checkout, and then let's say a Docker container name. I could check that out. I could do a Docker build, and then I'd have my next updated version of a container, no problem. So if you want to look at how we would build a new container, all right, so here I have my update that has the new run.sh. There's an original one, the original Docker file, and then the next iteration of it. If I were to say, okay, on Tech Symposium, I'm going to add another link. And I'm just going to put the Cal Poly Swift website. Very simple. So Docker build. Let's see if I have in my history. All right, so Docker build. C is for the tag. It's the name I want to name it. I'll call it version 3. And in this directory. The nice thing about Docker is because it's a copy on write system and it keeps all these layers, rather than having to do a Docker pull every time, if the image that you have is the latest, it bypasses that and uses that. So your build time is quicker. So when we saw that diagram of you could deploy Docker in 10 seconds, well, here's the example. It just finished. So if I go to Docker images, there's my version 3 tag. And I just made that code change really quick in the matter of, let's say 10, 15 seconds. So now if I were to deploy that here, to demo, let's call it demo 0. And all I do is on my script, I tell it to use the version 3. I drop my current. I'm going to drop the current nodes that are in play on this particular system. I'm going to do a remove, and then I'm going to replace them with this updated version. And then I should have 2 links when it fires back up. So I'm not a developer, but a developer would really like this on their local system because it's lightweight. You don't need like 8 gigs of RAM for a virtual machine. You could run any kernel you want, any version you want, but what was described earlier is that what you have is your kernel is better and best practice for the kernels you develop on. So if you should have a Fedora or Red Hat system if you're going to develop, or CentOS, if you're going to develop on that. And same for Debian or Ubuntu. So. And for Windows, there's boot to Docker. So on a Windows server, you could use boot to Docker, which does like a virtual machine, and that virtual machine can run containers. So there's still a possibility in Windows Windows realm to do that.
And you said that was, what was that? Just because, I mean, like, okay, so I don't do development as far as that is. I do pretty much setting up for the developers. In fact, one of my developers just put in a request that we're building right now for 3 new servers. So you can test his load balancing as far as that is. So I'm trying to think, as far as that goes, something as far as being able to deploy something this quickly would be freaking amazing. Because instead of having to put in the request and having to freaking work with, actually getting a new VM name for, 2 production, 1, dev, I can technically just spin up and, and that pretty much with this, as far as that is. But like I said, my original thing, until you said that, was the fact that, we're looking at, Windows versus Linux. But you're saying, because where would I be able to find more information on that? Just because, as far as
that's a separate thing, because if you're talking about a Windows application that you're developing,
it's technically a web app that he's developing that he wants to be able to make sure would be able to
work with a load balancer.
Yeah.
Okay. Yeah, because that's like
correctly.
session caching. Yeah.
It's going to be working with our databases as far as that is. So, because it's a dashboard that takes in all the actual information from all the different store calls that the reps do. And it kind of also helps plan out their days and all that kind of stuff. It's called itinerary manager. So he's just wanting to make sure that it will actually effectively work with the actual load balancer and everything else. As far as that is. But which, I mean, it's a pain in the ass because he's going to use it for like all of a freaking week, and then it's going to be dead. Like it's going to be, it's like a worthless thing that we're spending a week for, and then more than likely he's going to use it for, I wouldn't even say a full week. It's just going to be like him looking at it and being like, cool, it actually runs the way it does.
It'd be ephemeral in the sense that like you'd spin it up and then, hey, I don't need it, a couple days later or a week later.
So, I mean, that's because our developers do this all the freaking time. Like, and instead of just reusing it, they're like, oh, well, no, I need these new parameters.
Right.
And it's like, oh, well, you guys can scrap that one. It's like, in IT, it's just huge on just scrapping it left and right because, well, they won't have all the extra space and everything else. So I said something like this would be pretty awesome.
As long as whatever's needed for the web app, let's say the one way you could get around a Windows, if your applications run in Windows, my last shop I was at would use Mono as a project that runs Windows applications on a Linux environment, and it's an Apache module.
Okay.
And so that might be worth looking at. I don't know how flexible your shop is to consider that.
Well, I mean,
but that'd probably be the easiest because right now there isn't anything. Put it this way: there's talk about Windows 10 or the latest versions of Windows that might run in Docker, which would open up the ability to run Windows applications natively to a Windows Docker container. But that's going to be a long time before that becomes production worthy. Or even if it does come about, it's going to be a long time before it becomes production worthy. So if your app is portable in the sense that you can run Mono as a layer, that might be worthwhile,
Well, truthfully, they're supposed to be able to work with both Windows
and Linux. Apple. With Apple. Okay.
I mean, in a way, it should, and we do have CentOS, servers and everything else that we use. But I mean, I think just in this, I would be able to sales pitch, being able to get them to kind of move more towards this way, just because of the fact that instead of me having to be like, yeah, you have to wait a week for, that server that you're going to use for like 2 days, be like, oh, hey, wait a few, minutes and I'll have this, up and running for you. I think that in itself, just because of production time would be.
Yeah, you have lead and lag time between, hey, I need to put in the request, need the server provisioned, I need to get in there and configure it for what's needed.
Yeah.
Then you hand it off to the developers. They might use it for a day or a week. And then you go through the whole process all over again. Yeah, that really hinders your productivity of your developers.
Oh, yeah.
And so, like I mentioned with this, I could have, and I actually currently have 2 of my main developers that I work with their own instances of Docker. And they just push their image to one of our central servers that we test as like a staging area for dev test. And then from there, we don't currently have it in production, but that's the workflow we're doing. And it highly increases because if it's local to the developer's laptop, because it's that lightweight, their development cycle is going to increase, just as the Red Hat Docker pointed out. You could build, break, and dispose of images left and right. These really, if I were to go to the Docker directory, 698 megs. Tell me the smallest footprint virtual machine you could build. You'll be lucky to get a lightweight, minimal install CentOS or Fedora for maybe 3 or 4 gigs. Unless you really strip it down, this just rides above that. It does use the same kernel. It is using the same resources that are there. You can fine tune it if you wanted to. You could give it so much, because it uses control groups or C groups. That's what Google's developed. You could, give it more if it needed it for whatever reason. But the reality is you could deploy this in seconds. I just did an update. I just did an image update in about 10 to 15 seconds.
Well, that's what I'm saying.
Yeah.
That's just freaking amazing compared to the shit that I have to go through right now.
Yeah, like one application per one whole virtual machine is no longer in the model that should exist.
Yeah.
Assuming that you can get all your dependencies and everything else you're looking for into a containerized environment. Now, it's not a catch-all. The containers itself don't solve every problem. There are specific use cases, but the benefits that you get, especially that it's portable, what I could do is I could commit this and it's permanent. And it becomes, that layer gets hardened into and baked into that container. And then from there, you could compress that container and physically copy it off to other hosts. Or you could do version control, publish your Docker file to your GitHub, do a Docker checkout or a GitHub and Git checkout when you need it, and then Docker build off those files, and then follow that lifecycle. With each iteration of whatever sysadmins do, like, hey, we found a vulnerability. I'm gonna update this image. Is it okay to leave your same code that's in there, see how it reacts? If it's not happy, let's work on it. So the sysadmin, system engineers, they could just go ahead, get the security side done, knock it out, and then the developers, they could have the lag time of saying, well, yeah, go ahead. And then like we had done with the load balancer, you could put it into production, but not deploy to every host. You could have just some of the nodes out there, see how they react, put some logging and monitoring alerts, kind of see how it works. And if it's good, commit it. Once you commit it to Git, you have your tag. Cool. This is patched and the latest code works. The latest code doesn't work, send it back to your devs, let it go through QA, have them vet and fix any problems. The flexibility, you're adding this abstraction that gives you higher capabilities to have a smoother deployment and smoother maintenance of your whole operation.
Right.
So as long as a containerized environment fits for the application you have, it makes a lot of sense. And that's another discussion that they had touched upon called microservices. if you have this one server and it needs, let's say, 5 or 10 components that make that service, some of them could be put in containers. And then the nice thing is you could group those containers together. You could link containers. And when they're linked, they all talk to each other. So now, rather than have a VLAN or networking team say, hey, this server could only talk to these other servers, you're now pushing it up to the containers to say, hey, these containers they can only talk to each other. And the way you architect and add your security layers is a lot more flexible in that realm. And in certain respects, you could reduce overhead of maintenance of that for the networking guys. So,
well, I mean,
you know,
this just in itself to me makes more sense for especially what you have my job. Then like right now they're looking at solutions such as like using Azure and whatnot. Which yeah, I mean it's quick, fast, and being able to spin up couple servers. But also we're paying for it continuously. They take a shit ton of time to bring down. I mean that's just something that because Microsoft's going to try and milk their money as much as they possibly can out of it and everything else. Plus it's it's something that you wouldn't be able to post, and everything else locally on their own.
right.
Like versus this, you could just, as you're saying, spin it up real quick. It's small as shit. I mean, hell.
It's definitely worth looking at because, it depends on your shop. If they're flexible enough to be open-minded about how they might be able to build their apps.
About this. They like having more of,
Sure.
money in their pocket. That's
Sure. And if it'll change their minds on saying, hey, well, let's start building apps in Linux compatible environments, then it's really not that major of a change. I mean, I had developers that did C# and .NET programming, and it all worked in the mono module in mono. So web applications aren't that far off from being ported from a Windows only to both, if you still need both, or completely all, free open source. So, yeah, the last bit I was gonna talk about was just, again, stuff hits the fan, everything starts alerting you, yeah, to have contingencies with that, it's pretty much just having, how do you define an incident versus an event? Things are planned and unplanned. So if it's power outage or network stack or raccoons get in the data center, who knows? Something unplanned, right? Mm-hmm. If you have planned situations, you upgraded systems. Like I experienced a Cisco firmware upgrade that dropped Wi-Fi because it assumed that the DHCP was ran on the Cisco modules. We don't do it that way. So because of Cisco's failed assumption, we had Wi-Fi down because people can get IP addresses. So, you have to think about contingencies on planned and unplanned events, basically, and start putting standard operating procedures. How do you react? And then how you organize your communication structure is really important. I experienced this with 3 major outages at where I'm currently at. And if you don't effectively place certain people in certain roles, everyone starts broadcasting and talking to each other, and it gets chaotic pretty quick. So again, ICS being incident command system, it's just a model that could work for you if the high availability that we just talked about didn't work. So just stuff to keep in mind. So other than that, we kind of covered some other questions on Docker. It's a great platform. Again, to backtrack to the LinuxHA stuff, again, it's just how you architect what services matter to you. It could be internal DNS, external DNS. Again, you could cluster those into a LinuxHA cluster that, again, anytime one of the nodes drops, you got a backup. You got one in the environment. Or you got one in the cloud. As long as you got the networking stack in place, that compute resource could be anywhere you want, as long as the network is, architect right. It has all the right configuration. Couldn't see why you wouldn't be across Amazon Rackspace, DigitalOcean, in-house data center, and still all be serving all the same functions.
Yeah.
So, but yeah, I mean, if you want to talk offline for more like figuring out stuff for your shop,
I'll definitely be.
Yeah.
I'll be honest, man.
Yeah.
Just because I mean, I know because I'm gonna bring this up at work as far as that is and see like kind of about, you know, what it would take to actually get this, something along this line as far as that is. I mean, yeah, the Windows side of it sucks as far as, you know, the fact that we are Windows.
A lot of
but
dependency, yeah.
At that, we have
Dependencies.
Linux servers that technically this can be, you know, spun up on as far as that is.
Good. Just
So-
about wrapped up.
Okay, cool.
Yeah. Well, if you wanted to see it real quick, that's our cluster right there.
Oh, wow.
And it's just a simple Docker container. I went from no hyperlinks to adding hyperlinks without any interruption. And just, you know, HAProxy kept all the front end web servers going.
Fantastic.
And then other than that, it's got under the hood a 3 nodes, 3 virtual machines that are each capable of running the services that run on top of it. Particularly the virtual IP that they all talk to, that's where the ingress traffic comes in from the outside. Your DNS is always up because one of the nodes will take care of it. And then HAProxy, again, your load balancer, you're only as good as your single point of failure. If you have multiple nodes in an HA cluster, you're as good as how many nodes you have for fault tolerance. So, you know, actually, I'm on the management one. So I just run my handy little script that does a simulated outage. And then when it comes back up, it should show a new node replaced its resources. And then everything's still running. So there we go. Failed over from the management one up top in GM2 to node 1. All those services are still up. If I go to my containers, let's see, this session timed out, but all it needs is a refresh. And I'm still going. All my containers are still up. So,
Awesome.
yeah.
Well, I think we're gonna do closing remarks out in the
Main
main area. We've got a lot of water and stuff, so, you
Cool.
know, please, feel free to come out and join us.
Cool.